Hello guys, this is Prime Concept. In this video, we want to continue with our concepts of vectors. Remember in our previous video, we established cross product. We introduced that. We mentioned that there are two types of cross products, which is the arithmetic cross product and the geometric cross product. In that video, we were able to explain arithmetic cross product. So in this video, we're going to look at geometric cross product. Geometric cross product. So which is very important and very easy to understand. So before I move further into this concept, I want to use this opportunity to tell those of you that are watching and you are yet to subscribe to please hit the subscribe button. This is a way of showing your support to this channel. Like this video, comment, and then share with your friends. Tell them it is Prime Concept. Now, very quickly, whenever you talk about geometry, remember geometry talks about angle measurement. So when you say geometric cross product, it means that we can use this cross product to actually find or deduce the angle between two vectors. So we want to see how we can do this. Now, say we have a vector A like this. This is vector A. This is vector A. This is the magnitude of vector A. And then say we have vector B like this. This is vector B. And this is the magnitude of vector B. And then the angle between A and B is theta. Now, one of the things you should know is that the cross product can actually be used to find the area of a parallelogram. The cross product can be used to find what? Area of the parallelogram. Now, what it means is that if we want to find the area, we can actually convert this diagram into a parallelogram and see how we can use the cross product to find the area of parallelogram. But before I do that, I want to quickly point out that the geometric cross product actually tells us the extent to which two vectors are separated from each other. So it gives us how much separation two vectors would have, because this is vector B and this is A. So you can see that by the time we finish doing this derivation, you see that it has a relationship with sine, and sine tells us how much opening or separation two vectors have. Now, quickly, if I convert this, I'll have something like this. I'll have this. I'll have something like this, where for a parallelogram, what we know is that the opposite sides are parallel and also equal. So it means this can still represent our B. So in that case, let me put it here. So in that case, say I want to find the area of this parallelogram, I can decide to construct the height like this and extend this. So if I do this, this angle is actually same as this angle. Excuse me. This angle is same as this. So this is theta. Both of them are corresponding angles, and corresponding angles are equal. So I'm going to call this new height. I'm going to call it H. Now, if you consider SOHCAHTOA, excuse me, if you consider SOHCAHTOA, you notice that the opposite to this angle is H. So from SOHCAHTOA, we have that sine theta is going to be opposite, which is H, over hypotenuse. The hypotenuse is the magnitude of B. So if I make H the subject, I'll have that H is equal to the magnitude of B sine theta. This is what I have. So what it means is that if you want to find area of a parallelogram, is actually equal to base times height. That's the formula for area of a parallelogram. So, and remember we said that the area of a parallelogram is actually the cross product of those two vectors A and B. So it means that the area, I'm going to call it A cross B. This is the area, which is going to be the base times the height. What is our base? This is our base of the parallelogram from this point to this point, which is the magnitude of A. So that is magnitude of A times our height. And what is our height? Our height is H, which is actually equal to the magnitude of B sine theta. So this is what we have. Then because A cross B is actually a vector or a cross product, it has direction. So we're going to indicate that direction using a unit vector. So this is the formula for geometric cross product. And where is the direction of A cross B? A cross B is a vector that is perpendicular to both A and B. That is A cross B. So say I have something like this, what we already have. This is A and this is our B. Then A cross B is going to be this. It's going to be A cross B. So it has a direction given by this. The direction is perpendicular to this. So it means that, of course, I didn't draw this to scale, but it means that this angle here is 90. It also means that this angle here is 90. So that's what it means. That A cross B is both perpendicular to A and B. And we're going to see the implication of this statement I've mentioned. But let me quickly write it so you note. There's a point to note. A cross B is perpendicular to both A and B. So and this is going to give us a very important point to use later on when we're looking at multiplication of three vectors. Now, this is the formula which we may not be using in this form because we don't always want to find direction. So most of the times what we want to get is the magnitude of A cross B. So it means if I take magnitude of both sides, if I take magnitude of the two sides, I'll then have that the magnitude of A cross B would actually be equal to the magnitude of A, the magnitude of B sine theta. So this is what we'll be using. So what is the difference between them? The difference between the two formulas is that in this case there is a unit vector, right? And then this is just A cross B, no magnitude. So this would still be a vector. But in this case, this is the magnitude of A cross B. So this is no longer a vector. So I'm going to solve an example that will make it clear to you. And there is no unit vector in this case. So that is one of the things you should note about it. So this is a formula that will be more useful to us. Now, I want to point out something again from this. Now remember we did geometric dot product. When we studied geometric dot product, we arrived at a formula which is A dot B. For dot product, we arrived at the formula A dot B, which is this cos theta. For what we have now, it is sine theta. Now, somebody may ask, how do I know when to use this or when to use this? If they ask you to find angle between two vectors, you can use any of them. But most of the times, this is preferred because this formula would give us more information than this. So that's why once they tell you find the angle between two vectors, I would recommend you always go with this. So if they now specify under exam conditions like WAEC, NECO, IGCSE, your NEET exam, your JAMB exam, they now specify use the cross product to find the angle between two vectors, then you'll be using this. And what is the advantage of this over this? Very simple. The advantage is that theta cos theta can actually indicate to you whether the angle theta is an acute angle or an obtuse angle. So this can tell you. By the time you get negative of cos theta, if it is negative, you should know that is in the second quadrant, which is what? Obtuse. But you notice that sine is actually positive in both first quadrant and second quadrant. So it means if your angle is acute, the sign of that angle will still be positive. If it is obtuse, the sign of the angle will still be positive. So and that is why with this, you cannot really tell whether the angle is acute or obtuse. But with this, the moment you get cos theta and it is negative, it means that the angle lies in what quadrant? The second quadrant. So what I'm just trying to say is that this formula can tell you which quadrant, or can tell you the sense, a kind of direction, but not really direction, kind of the sense of the angle, right? Yes. So that if one vector is like this is A, and another vector lies like this can describe to you that this is how it is. But with this, it would always tell you that they would always lie this way. So even if this is the correct way, this one will interpret it this way. So that is the limitation this has. So let me not waste further time there. I believe that this explanation is really very clear to you. So when you want to really determine the direction, then you use your dot product. But meanwhile, what are we studying now? Geometric cross product. It is expedient for us to learn it and understand it. Now, so since we understand this, we want to do some deductions from this formula. What are the implications of this formula? Number one deduction or points I want you to note. Number one is that this is a scalar. This answer, this result is a scalar. The moment you take magnitude of a vector, your answer would always be a scalar. And I believe it is clear. What do I mean by that? If you have a vector, say A is equal to 2i plus 3j. This is a vector. But the moment you find the magnitude of A, it is a scalar because it will no longer contain I and j. Let's do it. The magnitude of this is going to be 2 square plus 3 square. And this is going to be 4 plus 9, which is what? It is 13. So I have root 13. Did you see that root 13 does not have I or j or k? So it means magnitude of every vector is a scalar. And if that is the case, we can conclude that our first deduction is true. Because this means magnitude of A cross B is going to be a scalar. Exam would ask you this, that which of the following options is correct? The magnitude of A cross B is vector, it is scalar, and so on. So this is a scalar. Number two deduction is that A cross B in itself is a vector. A cross B in itself is a vector, right? We're going to see it. We've seen this already when we did arithmetic. So, but we're going to see more examples. So this is a vector. Why this up one is a scalar. Very important for us to note. And I've also pointed another deduction here already, that A cross B is perpendicular to both A and B. So they are perpendicular. So you should note that. Another deduction I want to point out is that if A and B are parallel, if A and B are parallel or anti-parallel, that is theta equals 0 or 180 degree. So if A and B are parallel, it means that theta is 0 degree. If A and B are anti-parallel, it means that theta is 180 degree. But any of these two cases will give us same result. So if A and B are parallel or anti-parallel, then A cross B would be equal to 0. That is what it means. So if these two are parallel or anti-parallel, this result would always be 0. Right? Yes. Now, even without the magnitude is still 0. Now number 4, I want us to note, if A and B are perpendicular, then that is, okay, let me say that is theta equals 90 degree. Then it then means that A cross B, this is actually equal to this. This is what it would be, because if theta is 90 degree, sine 90 is 1.